Hello again, and welcome to the ninth Near Protocol Workgroup Call. Uh, I'm Victor, as you all know, and it's really great to see you all here again today. Really excited for us to look at NEP 536 and 540. So this is our agenda for today. First, we'll look at the objective of the call, and next we'll introduce everyone that's involved. Then we'll get into the main conversation of NEP 536, and then move on to NEP 540. And after that, we'll talk about implementation and open it up to Q&A. So hey, yeah, you could get active in the comments and drop any questions you may have. And now let's look at the objective for today's call. So hey, we're here to publicly vote and arrive at a verdict for NEP 536 and 540. We're also here to celebrate the time and effort that everyone has invested into this NEP. The four key roles in the NEP process: there's the author, who's the person that writes the proposal and presents it to the work group, the moderator, who facilitates this process, the reviewer, and an approver. Very quickly, to visualize this process, there's three phases: the draft, review, and the voting phase, and two possible outcomes: approve or rejected. So before we get into the NEP review, I would like to quickly highlight the authors of this NEP. Apologies if I mispronounce your names, but we have Evgeny and Bowen on the call, who are the authors of NEP 536. Thank you all for your hard work and submitting this NEP. I'm playing the moderator role today in facilitating this call. And now I would like each workgroup member to briefly introduce themselves for first-time listeners. Marcelo, do you want to go first?
Yeah, sure. Hi, everyone. I am Marcelo. I was working 2 years ago in Near Protocol. And after that, I was working in Aurora in the Rainbow Bridge. And I've been happy to be here at the discussing protocol upgrades. Looking forward to see upgrades.
Nice. Thank you so much, Marcelo. Michael, you're up next.
Sure. So, hello, I'm Michael. I follow a pretty similar path to Marcelo, actually. I was also a near core before joining Aurora. I am still working at Aurora these days, but I am also happy to still be active in the near core ecosystem. I still do contribute occasionally to near core, and always happy to discuss and ultimately vote on the protocol upgrades that we do here.
Sweet. Thanks, Michael. Marcin?
Hi, I'm Marcin. I used to work on New Core with the other folks, and now I'm working on zero knowledge proofs for Matter Labs, ZK Sync. And yeah, that's what I like doing on Friday evenings as a hobby. Looking at
Awesome.
naps and deciding on them. So thank you all for coming.
Yeah. Thanks for being here. And Bowen, you're up next.
Yeah, Bowen, working on protocol research and development for a number of years now. Yeah, happy to be here.
Thank you, thank you, thank you. Real legends in the building today. Awesome. Okay, so now that we have each workgroup member briefly introducing themselves, with that being said, I would like to move on to the actual NEP conversation. So first, we'll have one of the authors of NEP 536 present a summary of the NEP and why they believe it's important. And then we'll have the workgroup discuss their findings and ultimately arrive at a decision. Okay, great. I would like to invite Evgeny, one of the authors of this NEP, to share a summary. And yeah, the floor is all yours. Mm-hmm.
Hey, I'm Evgeny. I also worked on protocol a while ago, mostly on runtime. So that code is. So first, let's talk a bit on the background why we have refunds in the first place. So because Near is a synchronous environment, when you execute a transaction that may take multiple blocks, and by the end of the execution, the unused gas that, for example, was used for the function calls is being converted back to the near tokens and transferred back to the signer of the transaction. So that generated a refund for the unused tokens that were not spent on the transaction. There are a few types of refunds that we have. First, and that's the very simple one, is refund in near tokens. So imagine you're transferring tokens to the account, but that account doesn't exist. In this case, we refund you the tokens back to the original account, not the original, back to the predecessor, the one that sent the assets. That's the transfer refund. It's also possible for the function call. So when you make a function call with a deposit and that function call fails, basically panics, then the receipt considered failure and the tokens is refunded to the predecessor. So we don't touch these refunds in this particular NAP. The second type of refunds are for the gas differences, either in prices or unspent gas. So when a refund is, when a receipt is sent, we charge small amount in sent gas, and then we charge a second time at the execution time. So imagine a receipt having multiple actions, and the first action fails for some reason. Let's say it's a function call that fails, and there's multiple function calls. Then unexecuted actions effectively have a gas that is not being spent at the execution time. So that gas is converted to near at the prepaid gas price and being sent back to the signer of the transaction, the one who prepaid for all the gas of the entire transaction. So because the execution is asynchronous, the gas price might fluctuate between the origination when you issue the transaction and the moment when it's executed. So in order to account for this, historically, we had what we call pessimistic gas pricing. It basically inflated your gas price by the difference by how much it basically can increase per block. And it was like slightly higher. So instead of 1% per block, it was like 3% per block. So every single action, like effectively in the transaction, was having a higher gas price than it actually would be executed on, because of the 3% difference and 1% difference potential. And even a simple transfer would generate a gas refund to the original signer for this difference of 2% in the gas pricing. That was done to fight congestion and make it a bit more expensive to spam the network with this pessimistic gas pricing. If you like spam a lot of transaction in a burst, all paying the same amount. In reality, the current mechanism of gas price increase doesn't really work well. If one shard is congested out of 4, then the price would not increase. Now with 6 shards, if 2 shards are congested, we would still not increase the gas price globally. So there's no real protection of like this pessimistic gas price increases. So at the other time, it creates the overhead of accounting for the future receipt when we estimate the parameters of the network, because when you estimate how much actual compute you would spend, you would have to account for all the receipts that are flying back for a simple transfer. So this snap particularly eliminates the pessimistic gas price increase. That's the first change. We say that the transfer now will be charged at the current gas price without increase. So if transfer succeeds, there's no refund generated that would fly back to the signer, and that will eliminate kind of refund overhead of making a simple transfer. It also kind of like for other simple actions that do not involve function calls that are pre-computed gas and succeed, they're also not going to generate the refunds. The second change of the snap is previously we were not charging explicitly for the cost of the gas refund. So gas refund is effectively a transfer, so it has the original cost and the creation of action receipt. So it was charged when it was executed, but not when it was sent. So making explicitly charging gas for generating a refund will make gas estimation more robust. Now, because it will not be for free, or it will not be implicitly done. So the second change of the snap is we introduce an explicit gas cost of the refunds, but we do not change it for monitor refund. So the one that flies to predecessor is still free. And the third change that we wanted to add to this that created a discussion is whether we want to penalize function call refunds. So imagine you submit a function call that attaches maximum amount of gas. So in this case, 300 teragas to the receiver. And you only spent 5 of them, 5 teragas. So you have 295 teragas remaining that previously would be sent back to the signer. So the discussion was we wanted to penalize this either with fixed cost, which is, let's say, 5 teragas of this will be burned, and that will eliminate gas refunds for function calls that spent less, like that have less than 5 teragas remaining. And that number we wanted to increase over time, that over like, let's say 6 months or 1 year, the fixed amount goes to 300 teragas and we completely eliminate the refunds. But that creates a problem for the legacy contracts that do not were not conservative on gas, or they had a fixed cost built into the contracts that is hard to increase or like hard to maintain, and like contract might be locked, so we effectively will start burning gas for the action that were previously refundable. That will make certain interaction more expensive, especially with cross contract calls. So the second alternative was we introduce the cost of the refund in such a way that we penalize at most 5%, for example, of the remaining gas or some other parameter. So in this case, legacy contract will not be affected that much because the actual refund cost that we would charge will be slightly higher than 5% of the remaining gas. And only the like 300 teragas and spent gas will be penalized, which would force app developers to start thinking about not attaching the maximum amount of gas. On the other hand, it's not really critical to do this, because if we account for the gas refund in the actual gas cost, then that amount will be properly estimated and will be just included in the costs. So there is no real freezing for this stuff. At the same time, it doesn't penalize the development and DevX. So that's the background and like kind of explanation of that NEP.
Awesome. Thank you so much for your summary and for submitting the proposal and your ongoing work throughout the process, of course. Super great to see. Okay. So yes, the community has reviewed and discussed the SNP on GitHub along with the workgroup members. So next, I would like to invite Michael, one of the reviewers, to summarize some of the advantages and concerns that we saw in the comments. Yep, Michael, the floor is all yours.
All right, thank you, Victor.
Yep.
So, yep, as Evgeny covered, the main goal here is to reduce the overhead of having refund receipts that we simply don't need, based on the analysis that pessimistic gas pricing isn't really accomplishing what we want anyways. So that's a good thing to see. And then because it is now incentivizing users interacting with the blockchain, whether that's through a front end, developers building those front ends, or directly through a command line, incentivizing them to not attach the maximum gas when they don't need the maximum gas is nice, because it lets us pack the blocks more efficiently. The way that the transactions end up in blocks is based on the amount of gas that it could potentially spend. And so if you're attaching 300 teragas, but then only spending 5 of it or 10 of it, we've sort of lost that 150, 200 teragas worth of block space that is sort of being unused. So penalizing the overestimation will help us be more efficient in that regard. And then this is sort of a step in the direction of trying to make the whole process more efficient by maybe eventually getting rid of gas refunds. But as Evgeny said, that's not necessarily something that we'll aim for. It's just an idea. And then on the other side, on the concern side of this, I mentioned in the comments on GitHub that sort of arbitrarily choosing 5% as a penalty because it feels big enough but not too big, I don't think is a great way to make decisions. It would be nice for it to be somehow data driven, where we have some metric and we sort of agree that 5% optimizes this in some method or another. But obviously, it's better to make a decision that improves the protocol, even if it's a suboptimal improvement. It's still an improvement, so we don't need to bandy around too much with the data driven nature of things. Just as a side note, it'd be nice to see in the future. Now, because we are going to start penalizing overestimating gas, the flip side of that is we need to give developers a reliable way to estimate the gas, right? If basically the reason today that developers attach 300 teragas every time is because, well, that's the easiest thing to do. it's not like on other networks where you have sort of an easy RPC call to get the estimate gas for you, so you don't have to think about it too much. So it would be nice to see some tooling built up around this, because yes, we're happy about not overestimating the gas because of the efficiency, but we don't want to hurt the DevX experience too much. We don't want people paying for the overestimating costs unless we can give them the tools that they need to stop overestimating. And then finally, Marcelo did point out that pessimistic gas pricing did have a role, but as again you mentioned, it's not necessarily meeting that role. And there are other NEPs that we're not discussing today, but presumably we'll discuss in the near future, that are about congestion and about addressing congestion in a more robust way. So having a short term where pessimistic gas pricing is not present shouldn't be a big security issue for the protocol, because again, the congestion issue is going to be addressed separately in a timely manner.
Excellent. Thank you so much for that, Michael. Thanks for sharing. So now that we've heard about the advantages and the concerns of the SNEP, let's take a look at each working group member's opinion, which brings us to the voting stage. So based on the NEP process, we need 2/3 majority to move forward with this NEP. We've already had each working group member provide their voting indication on the NEP itself on GitHub, but here is the summary. So we had all 4 working group members leaning towards approval of this NEP. Before we formalize the decision, I'd like to ask if any work group members have any final comments or concerns. Yes, I can see Marcin.
Yeah, so while I agree that we should go forward with this, one thing that I mentioned on GitHub is we should make sure that explorers are showing clearly that this is the additional fee that was charged because the DevOps developer included too much gas. Because if we don't do it, people will just see like, oh yeah, Near is simply more expensive, Near is more expensive. And this is a different behavior than other chains, right? So again, if we don't do it, people will be like, okay, the new transaction costs $2 now. Okay, I'm gonna go somewhere else, without understanding that this might be coming from the fact that someone was just attaching too much gas. Because this is not a natural thing in other chains. So this would be my only request, is that really we invest in explorer/wallet/ways of showing users so they can also exert some pressure on the dApp developers.
Comment on this. During the implementation of this, I was thinking where to include this penalty. So if we include this into the burnt gas, then it will make estimators incorrectly estimate certain metrics. So instead, we can include this into the token burnt instead of the gas burnt. So the gas burnt will only be included for the actual cost of the refund, but the penalty can be included into the tokens burnt, but not in the gas burnt. And that will indicate that the tokens were burnt, but the gas charge was less.
Sure, but we have to show it on Explorer very, very clearly.
Yes.
Because the fact that this appeared from this field and not from this field, like, doesn't tell you much. It should be like a clear indication of like, hey, you're probably including too much gas, etc. So as I said, there is some work required on the Explorer side here.
Okay, thanks Marcin and Evgeny for your input. And yeah, thank you so much for sharing. Awesome. So with that being said, I would like to invite Evgeny again to talk about the next phase of implementation. Evgeny, the floor is all yours.
Right. So yeah, I made some progress on this, but it was taking a bit too long. So some most of the implementation is done. I was working on the tests, and with the recent change that introduced kind of a variable number of receipts in standard runtime tests based on the environment. So, and that's just extra changes that I need to complete. So it's in progress, but mostly done.
Awesome. Great. Okay. Thank you so much for that. And so now that we're done with NEP 536, we can move on to the conversation of NEP 540. And yes, once again, I'd like to call upon Michael to share some of the benefits and concerns of this NEP. Michael, do you want to go ahead?
Thanks, Victor. Yeah, so I guess I'll start with a quick summary of this one. So it's in the title, but the idea was Near has this storage staking, which is part of the protocol, and this is basically how you're allowed to store data on chain, whether that's data for a smart contract or access keys for an account or whatever. Just anytime you're storing something on chain, there's a minimum amount of Near that this account must hold to be able to have those bytes reserved. So we call this storage staking because you can delete that data and then your minimum balance is reduced correspondingly. And so you can sort of free up those Near if you wish. So the idea behind this was, it provides a persistent cost to storing things on chain because that Near is locked. You can't do anything with it. But it also is recoverable in the sense that if you delete the data, you get that Near back and you can do other things with it. So that was the idea. Storage staking, there's been a lot of discussion about, and there's basically we all agree it's not working as intended, but we don't necessarily agree on what mechanism should replace it. So there's still a lot of discussion about that. This proposal specifically was about, can we, as a stopgap measure, reduce that minimum amount of Near that's required on accounts on a per byte basis just to unblock development? Bowen points out in the description of that NEP that the cost to deploy basic contracts like a multi-sig contract has gotten kind of prohibitively expensive for average users, just based on the fiat price of Near these days. So, first bullet point here, reducing the cost immediately gives some relief to that. It is going to immediately alleviate the impact of Near having a higher price on being able to deploy contracts to the chain. And then, as I said, there was quite a lot of discussion on this NEP about alternative solutions, though we haven't really come to any conclusion quite yet on them. So let's go on to concerns. I don't think that this is a good idea because it creates a certain amount of risk, right? The token price, this is crypto, right? It's volatile. It could be up today, down tomorrow. Who knows, right? Like I don't, and unfortunately, fortunately and unfortunately, the process we have to update these things is a little bit slow, right? So there's no way that unless there was a proposal specifically for making it dynamic, there's no way that we can respond all the time, So if we decide to reduce it by 10x today and then the price drops back down, and so, okay, well, now let's have an NEP to bring it back up. I don't think it makes sense to put that work on ourselves. So reducing it down, I think, creates the risk that we will be undercharging for storage when the price changes in the future. And then, this doesn't actually address any of the underlying problems with storage staking itself. It is just sort of like a band-aid fix on top of storage staking. And again, I just don't think the risks introduced make up for the benefits. There's also a bullet point here about sort of potentially complicated things we could do in other storage cost solutions, but again, we haven't really agreed on any of those things. So I don't think it's necessarily a concern with this NEP specifically. It's just a concern with storage in general.
Awesome. Thank you so much, Michael, for sharing. And yeah, so with that being said, let's take a look at each working group member's opinion. And yeah, let's get to the voting stage. So like I mentioned earlier, the NEP process is based on a 2/3 majority to move forward with this NEP. And we've already had each working group member provide their voting indication. And so yes, we had all 4 working group members leaning towards rejecting this NEP. Before we formalize the decision, once again, I'd like to ask, does anyone have any final comments or concerns they'd like to raise? Yes, Marcin.
So yeah, so while this is painful, especially for some of the developers, or not necessarily developers, because if developers keep, experimenting with their contract, they don't really pay that much. Because as Michael said, these storage comes back, etc. It's especially frustrating for more sophisticated users that want to deploy a contract that already exists. Here, the multisig was one example, but there are a couple others. So one thing that I hope that, while this NEP failed, one thing I hope we'll be able to deliver soon is this, how it's called, like a global account, a global code storage, so that if a given code already exists in a given shard, then users trying to deploy it should not pay twice, kind of for the same storage, right? So in theory, having something like that, having a NEP like that, would be a proper solution for this painful thing.
Awesome. Thanks for that suggestion, Marcin. And yes, okay, great. So moving on to Q&As, does anyone have any additional questions they'd like to ask?
Well, maybe since we have people here, maybe let's discuss what is a proper solution. Since this is not a proper solution. I mean, I think what Marcin said about like global code storage, yeah, I mean, I think that makes sense, and it might actually become easier with stereo validation, since we do actually need to propagate the contract anyways, or at least in the current implementation. But I mean, I think that definitely addresses maybe a big chunk of the problem, but still, I think even just for like contract storage that's not related to contract code, but there's still is concern that I think was brought up by DevHub, because DevHub has this in their contract they actually store this components, right? The component code and so on. So that actually is also getting expensive when someone needs to deploy new widgets and so on. Yeah.
Yes, Marcin.
Yeah, but actually for the storage in contracts, I actually like the fact that this is expensive. As you know very well, this is the biggest challenge of blockchains growing, is like the state management becomes the biggest pain and has to synchronize whatnot, right? And some people, like, as you said, DevHub storing the code, this will be like a devil's advocate play, but like, hey, this is a good motivation for them to do things like compressing it, or maybe just storing a hash and storing the code somewhere else, and then people provide the code together with the hash when they want to do modify it. Like, there are a bunch of like solutions that will only show up if this is like expensive enough. Of course, while not going crazy, right? Because we still don't want to like limit the usability of the chain.
Yeah, I mean, I think I agree with the general sentiment that it should not be too cheap. Otherwise, we see a problem. We already see problems on like Base and a few other rollups where like it's like people spend like the storage. I guess Polygon to a certain extent as well. But I think I suppose partially the problem is that the price is denominated in near, and this can actually just become quite expensive at some point in the future, due to just like how market works. And ideally, we want to have a better mechanism somehow to deal with this, and it's actually not as easy. So I mean, at least I don't see an easy solution where you can tag the price to USD, because if you do it naively, then like what actually happens when the price just like goes up? Suddenly like your storage become invalid. not invalid, like you cannot actually access your account unless you just like deposit more. So then that becomes oh sorry, price goes down. I mean, anyways, like it can create this situation where like your account are kind of not usable anymore.
I mean, in theory, if you have the native USDC and you enshrine it actually into the protocol, which is like a huge separate like
Yes.
discussion, then
Yes.
and use that for storage staking, that solves this part. But yes, there are a lot of consequences of doing it.
Yes. It is very heavy lifting. Like you're like, okay, let's first build this huge hammer, and then like we can.
And then we
solve this.
perfectly get the nail. Like
Yes.
done.
Yes.
Another thing that was brought up as a conversation on the NEP was, I think Ilya originally proposed it, this idea of sort of dehydrating and rehydrating storage, where you don't demand that the validators actually store everything at all times. They are allowed to delete state and only keep the hash of the leaf in the tray. And then, you know, if someone needs that storage in the future, they would have to pay something to basically make some validator make it available again. And I think that's a reasonable idea to try to find a middle ground where you're, you know, not putting too much burden on validators, but also if stuff needs to be stored long term and is useful, then you know, the natural economic activity enables it. But my main concern with that is like what the actual DevX ends up looking like and how complicated it is, which I assume Evgeny wants to talk about as well right now.
Yeah, that's an interesting proposal, but it, like in the original protocol development, it always came towards like, can that be implemented on a contract level, so we don't have to put it on a protocol level? And that seems like a registration and like can actually be done on a contract level. Like you just store a cache and you delete it when you don't need it. It's just not automatic. So maybe if we provide exposure towards some kind of like merkleization towards the contract, then that's actually possible. But I don't think it's really necessary. We should just instead, majority of use cases actually, the storage on a contract is not really need to be this large, and like it mostly was designed to fight spam on tokens, but then it created a pain for the tokens. But in theory, users should cover this, and it's a one-time fee for the user. And then it's became somewhat cheaper to transact multiple times instead of like having to pay for the storage on every single call. So I agree on like that we should not drop it further. Otherwise, you'll introduce the extra complexity on validators network.
Yeah, I mean, I think with storage validation and sharding, we should not get into a situation where we still need this kind of state expiry, because like, well, first of all, it's only replicated now on chunk reducers, not on every validator. Most of them don't actually store the state, and so you can say that the cost of replication is not lower. And also we will limit the size of each shard to some reasonable number, so that if there's need to have more shards, then there'll be like more validators, and then more shards, and that you kind of scaling that way, rather than having to forget the state and then if someone insert them back later, which is like I mean, it gets complex for the end users, right? It's kind of annoying to deal with, and also like this, whoever stores the state, it's not clear what incentive they actually have, and you actually can lead to end up in a situation where some state is just forever lost, which is definitely not optimal, especially if that is like related to token balance or something like this, and like people are screwed.
I mean, it depends, right? In theory, if you have archival nodes that really kept the whole history, then the state is there, right? If they kept really the whole history of transactions.
Yeah, but like archival node is not, you can say it's not part of the protocol, right? Like today, the protocol, like for the network to keep running forward, it doesn't need an archival node.
Sure.
Awesome.
There was also, like, to address that, there was also this idea of combining this with a rent model, where basically you can choose between expiration or paying, like renting the storage, like continuously renting the storage. So you know it won't expire, but you need to pay for that. And yeah, that was an alternative to have good DevX and at the same time not let the state bloat. So basically only contracts that will be in use will expire, and very likely they will, like most of them won't come back.
Okay. Yes. Thank you all. Really looking forward to developments on these suggestions.
I think you got muted.
Oh, my apologies. Yeah, as I was saying, thank you to everyone involved and present on the call. We're really excited to work together and decentralize the development of NEAR. Congratulations to the authors of NEP 536 as well. And so just before we close off the meeting, I want to quickly highlight the ways you can get involved in the NEAR developer ecosystem. If you have a specific idea in mind, feel free to submit it using DevHub or any other existing communities to collaborate with. You can also submit your own NEP, and you can view all the NEPs and check out their updates on GitHub in the discussions. You're also welcome to join our Telegram group. If you're watching this, it's a great way to it's a great way to connect with others and see announcements for meetings like this. And you can learn about DevHub on our website and stay up to date on our social channels. I'll be posting the recording for this meeting and upcoming calls on all other social channels as well. So yes, once again, thank you to everyone. Congratulations to the authors, and have a great weekend.